Alright, this should be our last little part of section 1.6, I hope. Alright, so we'll see what's going on. It's kind of the same thing. It's all the same section, so it's all kind of related to each other. You got negative exponents on this one. There's no fractional exponents on this, but you do have negative exponents. And we need to simplify. But you got to remember some of those rules. Okay, remember when you have something that's got a negative exponent, okay, remember where you can flip it down to the bottom? But you got to remember also that you can only flip it down to the bottom if that thing is being multiplied by something else. So this stuff right here, this whole parentheses is being taken to the negative first. So is that whole thing being multiplied by something? Sure, you don't see it, but what's there? It's a 1, right? Or if you had like a 3 out front or something like that, okay, yeah, that's being multiplied by that. If it's being multiplied by something, then I can take it and flip it to the bottom and change the sign of the exponent. Remember doing this stuff? Right? If I had like x to the negative third, y to the fifth over x to the, I don't know, fourth. Let's say we had something like that. Okay? You can take this, flip it to the bottom, and make that x to the positive third, and it goes away here, right? But the only way that you can do that is if that thing is being multiplied by something else. Was this being multiplied by something else? Absolutely. It's being multiplied by y to the fifth. That allows you to do that. What if you had this, though? What if you had x to the negative third plus y to the fifth over x to the fourth? Here's a situation we haven't encountered yet, as I don't think we have. All right, until this section right here, this little example right here. We cannot, listen, we cannot take this, flip it to the bottom, and make it x to the positive third. Because I can't take this. If this is being added to this, I can't separate it from this addition and then throw it to the bottom and expect to multiply those two things together. Because when I flip it, what I'm doing is I'm actually multiplying by the reciprocal, or the inverse, okay, if you want to say that. I'm multiplying by the inverse. I can't do that with an addition problem, right? So if this is being added to this, I can't just take this and flip this to the bottom. No, no, no. Can't do it, all right? So I almost hate even writing that out because some of you might see that and go, oh, yeah, he flipped it to the bottom. No, I'm saying, no, you can't do it. When can you not do it? Is when that thing's being what? Added to something else. Now look at the example we're going to do here. Do you see something in that situation? You do. You see things that are being added, don't you, with negative exponents? So, can you take x to the negative first, flip it up to the top? What do you think? Anybody here? Okay. No, you can't. We just talked about it. Why not? Because this thing is part of an addition problem. You can't do it. If it was multiplied, if it was x to the negative first and then no plus in there and it was just right next to y to the negative first, they're sitting right next to each other, that means they're being multiplied. Then you could take this, flip it to the top, take this, flip it to the top. But in this situation, you can't do it. All right? You've got a plus sign right there. Could you take this stuff up here and flip it to the bottom? Sure, absolutely. This is being multiplied by 1, isn't it? So yeah, I could take this and flip it down to the bottom. I'm not going to do that, though. All right? I'll show you a little bit better way to do this. So, what in the world are we going to do to this stuff if I can't take it and flip it up to the top? That's the only thing I knew what to do, before today, was just, flip it to the top or flip it to the bottom. That's all I could do. So I got to have another way about this. So watch very carefully. All right, this is an important step. This is a step that I teach all the time, but students forget it. For some reason, students just forget to do this. So watch what we do here. And how do you know to do what we're going to do? Well, you know we're going to do this process because of this plus sign. All right, because this is a negative exponent plus this to a negative exponent. When you have this situation, then you do what we're going to do right now. Let's just forget this whole denominator. Forget that even exists. What if I just had x plus y to the negative first, and I didn't want a negative exponent? What would I do? Okay, but not on the bottom here. But watch, what if I just had x plus y to the negative first? What if that's all I had? Forget all that stuff above here. Forget it all. All right, just look at this by itself. What would I do to get that to be a positive exponent? I'd do what? 1 over x plus y to the what? To the first, or just to the x plus y. Would you agree with that? So what we're going to do is we're going to take this philosophy and we're going to do it up here. So I'm not taking this and I'm not flipping it to the bottom. All right? That's not what I'm doing right here. Even though technically you could do that. That's going to mess things up. It's going to make things really ugly if I do that. So what I'm going to do is take a look at this just in the top. Forget the bottom even exists. What I'm going to do is go 1 over x plus y. See that? Now I could put it in parentheses, but do I really need to? Because it's doing what? It's being taken to the first power, so I really don't need that parentheses there. If it was to the second power, yeah, I would definitely need it. If it's to the first, you don't need it, so I'm just going to write 1 over x plus y. See what I just did? This stuff right here, all I did was rewrite it. I didn't chuck this all the way to the bottom, did I? All right, I just made it 1 over x plus y. You good so far? Okay. Now let's do this. We're not going to take this. I had a big long talk about it at the beginning of this lesson. I'm not going to take this and flip it up to the top. I am not going to take this and flip it up to the top. But let's pretend that the only thing that exists is x to the negative first. Forget all this stuff around here. Okay? Let's pretend that this is the only thing that exists. And let's get rid of this so it just doesn't mess everything up. All right, let's bring that up there. What if that's the only thing on this page, x to the negative first, and I said make it into a positive exponent? What would you do with this? 1 over what? To what?
To the first.
Right, x to the first. All right, that sounded like you said to the negative. You didn't say that?
So that to the first.
It's just 1 over x to the first, correct. Okay? But I don't really need the first there, do I? Would you agree that that's what we would do here, x to the negative first? We gave that as a definition a long time ago when we first started talking about negative exponents. So x to the negative first is the same as 1 over x. What if I just had y to the negative first and nothing else? There's nothing else on this page, just y to the negative first. How could I write that as a positive exponent? 1 over y. Would you agree? So what I'm going to do is take that philosophy, take that line of thought here, and come up to here. So let's do this. Let's take x to the negative first. How can I rewrite x to the negative first? 1 over what? X. How could I rewrite y to the negative first? Put a plus sign, right, because you got a plus in between there. What would I write that as? 1 over y. Everybody see that? I did not take this and flip it to the top. I didn't take this and flip it to the top. See it? Why couldn't I do that? It seems like it would be just as easy if I took that to the top, make that an x, put that to the top, make that a y. But I can't do it because of this plus sign right there. Everybody see it? So that's really important stuff. All right, let's get rid of all these lines and stuff. Let's get rid of that. All right, this is what, right here is what we want to simplify right now. And what could we simplify? Well, the top, you really can't do anything with the top. So I'm just going to leave it 1 over x plus y. But I can do something with this stuff right here. No. You got to think of the rules for adding fractions. Look, can I go 1/2 plus 1/3 and make it 1/5? Why are we thinking about it? That shouldn't even be a thought in our head, should it? Okay? You can't add fractions just by adding up the denominators. That flies in the face of everything we learned since elementary school about adding fractions. What do we have to do? If I was going to add 1/3 or 1/2 and 1/3, find a common denominator, right? When you add fractions, you have to find a common denominator. What would it be with 2 and 3? 6. What did we do to 2 and 3 to get 6? Multiply them together, all right? Right, 2 times 3, right? And then what'd you do? 2 times what? 3, so 1 times 3, right? 3 times 2, 1 times 2. You get it? So that is 5/6. That's way different than 1/5, isn't it? So, to answer your question, can you do that? Can you just go 1 over x plus y here? No, you can't. You got to find a common denominator. So I went through this whole thing for a reason, because I want you to relate it to this stuff up here, because x just stands for a number, doesn't it? Y just stands for a number. Well, make that number x 2, make that y 3, just to kind of get you an idea of what we're doing here. So what do you have to do here? Find a common denominator. I got an x and a y. What would my common denominator be? It'd be xy, wouldn't it? Just like it was 2 times 3. Agreed? Now, what'd you do? What'd you do to x to get to xy? Times it by y. So what do you do to the top? Multiply that by y. 1 times y, it's y. Put a plus. What'd you do to y to get to this denominator? Multiply it by x. So what do you do to this? Multiply that by x. So you get an x. With me? So you have to do that. You got to find a common denominator. It's the only way you can add fractions together. Now what we can do is this. This is a big old division problem now, isn't it? See? It's that complex fraction, what we talked about a couple lessons ago. See that? I've darkened that in. It's a big old fraction. That's the top, and that's the bottom right there. Everybody see it? So what do you do when you divide? You multiply by the reciprocal. So let's take the top, keep it the same, and instead of dividing by this, we multiply by the reciprocal. So what is it? xy over y plus x. Or, it'd be easier to write just x plus y since that's already x plus y. You get it? Now this is a multiplication problem. Does anything cancel out? Does this x go into this? Does this y go into this? No, it doesn't, because you got this addition down here. What are they doing now? Now this is a multiplication problem. You don't find a common denominator with multiplication. Alright, what do? Just multiply straight across, right? If nothing cancels out, which we've already determined, nothing does cancel out here. So what do we have to do? Just multiply straight across. So if I multiply the top, what do I get? Just xy. Multiply the bottom. You could write it a couple different ways, but let's write it as nice as we can and as compact as we can. So it's x plus y times x plus y. So it's the same thing as x plus y squared, isn't it? If you wanted to, you could write it x plus y and then right next to it another x plus y. That would be okay. If you wanted to multiply it out, you could. Do you really need to do that, though? No, you don't, because it doesn't make it any more simple. This is probably the neatest, most compact way to write this problem. Just like that. And that's your answer. Just like that. All right? Nothing cancels out here because you got an addition in here, plus the things being squared. But what's the key to this problem? The key to the problem is to work these things individually. Don't take this and flip it to the bottom of the whole fraction. Don't take this and flip it up to the top, or this one. What do? We keep it in the numerator and just make it 1 over x plus y. We keep this in the denominator and make it 1 over x. We keep this in the denominator and make it 1 over y. There's a plus sign between them. Then what do? Well, there's nothing you can really do to the top, but on the bottom you can add those up. And how do we add fractions? We find a what? Common denominator. That's right. Find a common denominator. It's xy. We already talked about how to find the top. Then you look at it. It's a big old division problem. You take the top divided by the bottom, which is the same as the top times the reciprocal of the bottom, right? Multiplied by the reciprocal. And so we flipped it, right? We took this, we flipped it, just like this. We look to see if anything cancels out. A lot of times you'll have problems that, yeah, there will be stuff that cancels out to make it work out nice and easy. In this particular problem, nothing canceled out. So you just multiply straight across the top, straight across the bottom. That's the nicest, easiest way to write that answer, so we just write it like that. There's all kinds of ways. You could have written it xy over x plus y and then x plus y. You could have done that. That would have been okay. I would have accepted that. Not a big deal. Now, if you really wanted to, this would be a waste of time, to tell you the truth, but you could multiply that thing out if you wanted to. What would that be? X squared plus 2xy plus y squared. If you wanted to write it like that, fine, okay? But why go through that extra effort? Would you agree? There's really no reason to go through that. But I would give you this, I would give you this, and I would give you this. You don't have to have all three, obviously, but you can pick any of those. I would pick this one right here. We good? If you weren't really sure about it, go back, okay, and look at the video. Stop it, pause it, write the stuff down, think about what I said, all right, and before you go to the next problem. All right, yes, I do. All right, enough of that. So I think we're finally finished 1-6. Now we can just give you a couple more. I'm going to give you part D today for the homework, and then in the next couple days I'll give you a couple more reviews. We'll take a quiz on Friday, and we'll be done with 1-6 by Friday. All right?